All right, so we're going to continue to work our way down the upper limb, and the next 4 labs are going to be completing the upper limb. So today in lab, we're going to study the brachium, which is the upper part of the arm. We're going to then on Monday, we're going to do the anterior surface of the antebrachium or forearm. Next Tuesday, we're going to do the anterior surface of the palm, or what we call the palmar surface of the hand. And then we're going to do the posterior surface of the forearm. Actually, I'm a little off. Today's Tuesday, so doing brachium today, antebrachium Thursday, palm of the hand Monday, and then dorsal surface of the forearm and hand next Tuesday. Next Thursday's lab is actually going to be on the skull and face, but that lab will not be included on the next exam. The next exam, which is actually 2 weeks from yesterday, is only going to cover the remainder of the upper limb. Anything on the skull and face is actually going to go over onto the third exam. This is the only situation this semester where I think that happens, where we have a lab that's not going to be included on that exam. So we've just got 4 more labs to complete the upper limb. And by the way, the study guide for the next exam, the second exam, is already posted on my courses, along with the content for this week. Hopefully some of you have already noticed that. All right, today we're going to focus on an area called the brachium. And before we get into talking about the structures, I need to clarify some terminology that I find, unfortunately, very confusing. When an anatomist talks about the arm, they do not mean the entire upper limb. To an anatomist, the arm is only the area from your shoulder to your elbow, what we might call the upper part of the arm. But to an anatomist, that is the arm, just from the shoulder to the elbow. Then the rest of the upper limb, from the elbow down to the wrist, they would call that the forearm, and then obviously the hand. I find that very confusing because to most of us, we've grown up our whole lives. When we think about the arm, we think about the entire upper limb. Nobody in common everyday usage, when they say arm, nobody's referring to just the upper part of the arm between the shoulder and the elbow. So for that reason, I prefer not to use the English terms arm and forearm, because arm especially is very ambiguous and confusing. A lot of your books, unfortunately your textbook, I think, does use the term arm, but they use it in the way that an anatomist would use it. So when they talk about the deep artery of the arm or the medial cutaneous nerve of the arm, they're talking about just the upper part of the arm from shoulder to elbow. I prefer to use the Latin terms instead. I prefer to use the term brachium to refer to the upper part of the arm from the shoulder to the elbow, because brachium is not an everyday English word. It doesn't have any common meaning in the English language. So it's much easier to think of the brachium as being just that upper part of the arm from shoulder to elbow. And then when we get beyond the elbow, instead of using the English term forearm, I prefer to use the term antebrachium, which again is the Latin term, which literally means forearm, but it's less ambiguous because it's a Latin term. So just be aware, whenever you read the word arm in an anatomy book, they're only referring to the upper part of the arm. All right, so I want to go through the bones in this area, and then add muscles, nerves, and arteries, and so forth later. We do need to review a few structures in the scapula, and if you look in the study guide for the next exam, the scapula is still included as a bone that you're responsible for the next exam, because several of the muscles that lie within the brachium have their origins on different parts of the scapula. So for example, the coracoid process. One of the questions on yesterday's lab exam was name a muscle that inserts on the coracoid. The only muscle that has its insertion in the coracoid is the pectoralis minor, which is one of the muscles that we studied in the pectoral region. But there are also two muscles that have their origin on the coracoid, and these are muscles that are found in the brachium. And we'll come back and talk about those soon. There are also these two small roughened areas that lie superior and inferior to the glenoid fossa. The supraglenoid tubercle just superior to the glenoid, and infraglenoid tubercle just inferior to it. And these are also associated with muscle attachments for some of the muscles in the brachium. Now I want to move on and continue down the humerus to the distal end of the humerus, and also talk a little bit about some of the bony landmarks in the two forearm bones, the two antebrachial bones, the ulna and the radius, simply because the muscles in the brachium are primarily, most of them are crossing the elbow joint, and therefore they are inserting on the bones of the antebrachium and moving those bones at the elbow joint. So it's important to learn these landmarks so we can understand the insertions of the muscles of the brachium. As you can see, there are quite a few landmarks in this area, and it's a little overwhelming when you first look at it, but I'll try to walk you through it in a way that makes it a little more clear, hopefully. First of all, at the distal end of the humerus, you have a pair of surfaces that form the elbow joint. And collectively, these are referred to as condyles. So I'll write that out here. Not very clear, but condyles. A condyle refers to an articulating surface or a joint surface at the end of a long bone. But here in the distal end of the humerus, the two condyles have very unique shapes, and so they get special names. So on the medial aspect of the distal end of the humerus, this particular condyle is referred to as the trochlea. And it has a shape that resembles a pulley. It has this indentation in it that looks like the wheel inside of a pulley. This is the part of the humerus that articulates with the ulna in the antebrachium. Then on the lateral side of the distal humerus, the condyle over on the lateral side is this round ball-shaped structure called the capitulum. And that forms an articulation with the radius, which is the other bone of the antebrachium. There are also a pair of structures known as epicondyles, which simply means above the condyle. So since the trochlea and capitulum are both condyles, these two bumps that lie just superior to those are these epicondyles. There's one here on the medial side, just above the trochlea. This is called the medial epicondyle. And then there's one on the lateral side, just above the capitulum. So that's the lateral epicondyle. These are going to turn out to be very important when we get down into the antebrachium, because many of the muscles in the antebrachium, in the forearm, have their origin on both the medial and lateral epicondyles. Then superior to the epicondyles are a pair of ridges, and these have the word supra in them, referring to superior. So these are even higher up than the epicondyles. These are supracondylar ridges. They're called ridges because they actually are sort of like a sharp crest that lies above the epicondyle. So there's one on the medial side and one on the lateral side. And these are also going to turn out to be important once we get down into the antebrachium, because some of the forearm muscles have their origin on these supracondylar ridges as well. Then we cross the elbow joint and we get into a few landmarks on the two bones of the antebrachium. First, the two bones of the antebrachium. So this is the ulna, which is the more medial of the two bones. And then this is the radius, which is the more lateral of the two bones. one of the alumni who welcomed all of you to the listserv and welcomed you to the RIT program, included a little mnemonic or a little acronym. She said, RIT, radius is thumb. What she means by that is that the thumb is the most lateral of the digits in the hand. So there's a really bad drawing of a hand. The thumb is the most lateral of those digits when you're holding the hand in anatomic position. The radius is the bone that lies on the lateral side of the antebrachium. So this was a little mnemonic that she used to help her remember that the radius is lateral. So radius is thumb, referring to the fact that both of those things are on the lateral side of the upper limb. Very important to keep straight, which of these two bones is lateral and which of these two bones is more medial. The ulna would be on the medial side or the pinky finger side of the upper limb. So there are some landmarks here that help to form the elbow joint. There's a thing called the trochlear notch, which is part of the ulna. It's a deep indentation, a deep notch on the proximal end of the ulna, and it wraps around the trochlea of the humerus to form part of the elbow joint. Immediately distal to the trochlear notch is a pointed structure known as the coronoid process. Be very careful. Don't confuse this with coracoid, which is on the scapula. And then a little bit distal to the coronoid process is the ulnar tuberosity. It's just a large roughened portion of the ulna. This is the insertion for one of the muscles of the brachium. Over on the lateral side is the radial head, which is just a disc at the proximal end of the radius. And it has a shallow little fossa on its proximal surface that forms the articulation with the capitulum in the elbow joint. Then there's a little bit of a skinny neck on the radius, followed by a large bump called the radial tuberosity. And this is the primary insertion point for the biceps brachii muscle in the brachium. If you flip the elbow around, now the radius is on the right here, so that would be lateral. Remember, radius is thumb. And then the ulna on the medial side. You can see a couple of additional features here. The ulna has that trochlear notch, which is wrapping around the trochlea of the humerus. And then there's an extension of the ulna that points up proximally, or is pointing up superiorly. This is known as the olecranon or olecranon process. This is the structure that forms the point of your elbow, the pointed tip of your elbow. And this is the insertion site for the triceps brachii muscle. When the elbow is fully extended, that olecranon fits into a cavity or a fossa on the posterior surface of the humerus, known as the olecranon fossa. The elbow joint, as it turns out, is not just a single joint. It's something that's known as a compound joint because it's really a couple of joints rolled into one. On the medial side, we have what's known as the ulno-humeral joint. In other words, the joint between the ulna and humerus. This is where the trochlear notch of the ulna wraps around the trochlea of the humerus. So that forms half of the elbow joint. And then over on the lateral side, we have the radiohumeral joint. In other words, the joint between the radius and the humerus. And this is formed between the radial head and the ball-shaped capitulum of the humerus. Now, even though there are two joints in one, both of these parts of the joint have just a single type of motion that occurs. The entire elbow joint is capable of just one axis of motion or one type of motion, which is simply flexion extension. So you flex the forearm or flex the antebrachium at the elbow joint, and you extend the forearm or extend the antebrachium at the elbow joint. It's very important to remember something here about how you describe these motions. When you flex the elbow, you are not flexing your arm, because remember that to an anatomist, the arm is just the proximal part of the upper limb, just from the shoulder to the elbow joint. So when an anatomist says flexing the arm, they mean moving the humerus forward at the glenohumeral joint, not flexion of the elbow. When you flex the elbow, you're not flexing your arm, you're actually flexing your forearm relative to the arm. So you're flexing the forearm at the elbow joint. Or likewise, if you extend the elbow, you're extending the forearm at the elbow joint. Because it's when you flex and extend at the elbow, you're moving the forearm. You're not actually moving the arm, at least, you know, the way the arm is defined by anatomists. All right, let's take a look at the muscles in the brachium. And you notice here, this is a slide from the Netter collection. Even on this Netter slide, they use the term arm, but they're using it in the anatomical sense, just referring to the upper part of the arm. There's a series of cross-sectional slices here showing the arrangement of the musculature around the humerus. And if we jump forward and zoom in on one of those cross-sections, what you see here is that the muscles of the brachium are segregated or subdivided into two compartments. Now, when I refer to a muscular compartment, what I mean is a group of muscles that are surrounded by a continuous layer or envelope of fascia. So in this case, the muscles of the anterior compartment of the brachium are surrounded by a single layer or envelope of fascia. Likewise, the muscles of the posterior compartment, which lies posterior to the humerus, these are also surrounded by a layer of fascia or an envelope of fascia. So I could draw, if I can get my cursor to come up here, where's my, oh, there it is. So I could draw an envelope of fascia that goes all the way around the anterior compartment, and then another envelope of fascia that goes all the way around the posterior compartment. Now notice that there are two places where these fascia envelopes come together. Over here on the lateral side of the brachium, the anterior and posterior compartments come together. And those two layers of fascia form a very tough membrane known as the lateral intermuscular septum. Same thing happens over here on the medial side. That anterior envelope of fascia around the anterior compartment joins the posterior fascia envelope, and together they form something called the medial intramuscular septum. And nerves and arteries tend to be located within these intramuscular septa. So you notice over here on the medial side, with the medial intramuscular septum, I'm going to change colors here. There's a bunch of nerves and arteries and even a couple veins that are embedded within that septum on the medial side. These would be things like the brachial artery, which is the continuation of the axillary artery running down into the brachium, as well as some of the nerves coming from the brachial plexus, like the ulnar nerve and the median nerve would be included within this medial septum. And then over here on the lateral side, you've got that lateral septum, which would contain things like the radial nerve, which rests right up against the humerus, as well as the deep artery of the arm, or the profunda brachii artery. So let's take a look at the muscles that are found within each of these compartments. We'll start with the anterior compartment. So here's an anterior view of the muscles of the anterior compartment of the brachium. There are three muscles in the anterior compartment of the brachium, but only two of them are visible here. There's the biceps brachii and the coracobrachialis. So those are the two muscles you can see here. In the next slide, we'll look at a slightly deeper dissection where we can see that third muscle in the anterior compartment. The coracobrachialis has its origin on the tip of the coracoid process. So I mentioned earlier that there are a couple of muscles that have their origin on the coracoid. So here's the coracoid process up here, and you can see the origin of coracobrachialis right there on the tip of the coracoid process. Now the name of the muscle tells you its attachments. The first part of the name, coraco, tells you that it's originating on the coracoid. And then the second part of the name, brachialis, is referring to the fact that the muscle inserts into the brachium. It's actually inserting on the shaft of the humerus itself. You can't quite see that, but if you could follow this muscle down a little farther, right about in this area, the coracobrachialis muscle would be inserting into the roughly the midpoint of the shaft of the humerus. So the coracobrachialis is only crossing one joint. Since it originates on the scapula, the coracoid specifically, but that's part of the scapula, and it inserts on the humerus, the only joint that this muscle is crossing is the glenohumeral joint up here, between the glenoid fossa of the scapula and the head of the humerus. So that means that this muscle can only act on the glenohumeral joint. So it can only move the humerus relative to the scapula. It really doesn't have a lot of function. It's not a very substantial muscle, and it doesn't do a whole lot. It's a fairly weak adductor with a D, adductor of the humerus. It helps hold the humerus tightly against the body, so that would be adduction. It's a very useful muscle if you're trying to carry a notebook or something under your arm, and you're using your arm to kind of press the notebook up against your chest. Coracobrachialis would be helpful for that motion. It's a very, very weak flexor of the humerus, so it flexes the arm or flexes the humerus a little bit at the glenohumeral joint, but that's pretty minor. I'm going to skip the innervation of it for a second because it turns out all these anterior muscles have the same innervation, so I'll just cover that all together in just a second. The biceps brachii is a muscle that you're much more familiar with. You know, whenever people do curls, you know, they lift weights and they curl the weights up. They say that they're working out their biceps. The name biceps means two heads. And by the way, the S here does not make this plural. So there's no such thing as a bicep. A lot of people will write that incorrectly. It always has the S on the end, even if we're only talking about one of them. So it's biceps brachii. So this is the biceps of the arm, or the two-headed muscle of the arm. Biceps literally means two heads. The reason it's important to call this biceps brachii, don't just call it biceps, because you also have a biceps in your thigh. There's a biceps femoris, one of the hamstring muscles in the back of the thigh. So this is specifically biceps brachii, the two-headed muscle of the arm. So the two heads that give the muscle its name are the short head and the long head. The short head originates right next to the coracobrachialis on the tip of the coracoid process. So in matter of fact, if you trace these two muscles up to the coracoid, it's very difficult to distinguish them because they're essentially fused together up here at the coracoid. It's only as you move a little bit farther down or a little bit more distally within the brachium that the separation between the short head of the biceps and the coracobrachialis becomes more obvious. But that's the short head. And then lateral to that is a tendon known as the long head of the biceps brachii. Now, when you look at these two heads, you might scratch your head and wonder, why is the long head called long? Because it sure as heck looks shorter. That's because you can't see the whole tendon of the long head. A lot of it's hidden. The long head of the biceps brachii is originating way up here on the supraglenoid tubercle of the scapula. Its tendon then crosses all the way over the head of the humerus and actually lies in the intertubercular groove of the humerus between the lesser tubercle, which is here, and the greater tubercle, which is more lateral. So the tendon of the long head of the biceps is going over the head of the humerus down through the intertubercular groove. And then it's only after it passes through the intertubercular groove that it becomes obvious that you can actually see it. So the long head really is longer than the short head. It's just that most of it's buried and you can't actually see it. Eventually, those two heads of the biceps brachii join together and form one great big muscle belly. And then if you follow that muscle belly down to its insertion, most of it dives deep just past the elbow and inserts into the radial tuberosity, the bump on the medial aspect of the radius. So most of the attachment, or most of the insertion of the biceps is on the radial tuberosity. But in addition to that tendon inserting on the radial tuberosity down here, the distal end of the biceps also gives rise to these fibers called the bicipital aponeurosis. And these spread out and just merge with the fascia of the antebrachium, the fascia of the forearm. So most of its insertion is on the radial tuberosity, but it also inserts into this thing called the bicipital aponeurosis that fuses with the fascia of the forearm. The biceps brachii is actually crossing two different joints because it has its origin on the scapula, up here, the short head originating on the coracoid, the long head originating on the supraglenoid tubercle. So both of those are origins on the scapula. So that means that the two heads of the muscle are actually crossing the glenohumeral joint or shoulder joint. And then the distal attachment, the insertion, is either on the radius, which is one of the forearm bones, or the fascia of the forearm. So that means that down here, the muscle is also crossing the elbow joint. That means it can act on both joints. And actually, an interesting little piece of trivia, the biceps brachii muscle doesn't connect to the humerus at all. There's absolutely no connection between the biceps and the humerus. It's originating entirely on the scapula and inserting entirely in the forearm, and doesn't ever even touch the humerus at all. Well, except for this little bit up here on where the tendon is in there, but it's not actually connected to the humerus at all. So that means, since it's crossing both of those joints, that means it could actually act on both joints. But despite the fact that it crosses the glenohumeral joint, it plays a very, very small role in any kind of movements of the glenohumeral joint. It could function as a very, very weak flexor of the humerus at the glenohumeral joint, but that's a very, very weak role. The other role for the biceps is down here in the elbow, and this is what we tend to think of the biceps as. You know, we tend to think of it as a powerful flexor of the elbow. So that's really its primary role, is to flex the forearm or flex the antebrachium at the elbow joint. Now, the biceps brachii also has one other very important role. So its primary role is a flexor of the antebrachium at the elbow. But it has another very important role down in the forearm. And this is a little bit harder to understand, but remember I said that the biceps tendon, which is kind of disappearing from view down here just beyond the elbow, it's inserting on the radial tuberosity, this bump that sticks out from the medial aspect of the radius. I can't remember if I have a slide to show this or not. Hang on a second. Whoops, all right. We're still drawing here. All right, no, I don't have a slide to show this movement, but if you think way back to the very first day of class, I was talking about the movements of pronation and supination in the forearm. And these are two movements that occur between the two bones of the forearm or antebrachium. The ulna, which is the more medial of the two bones, always remains completely stationary. It's the radius that's moving. And the radius can either lie parallel to the ulna, sitting lateral to it, or the radius can cross over the ulna so that the two bones are in sort of an X shape, sort of crisscrossing one another. When the radius crosses over the ulna, the hand turns posteriorly in anatomic position so that the palm would be facing posteriorly. That's a motion that we call pronation. I'm going to stop sharing here for a second so I can demonstrate this for you. So it's easier to see this if I bend my elbows, if I flex my elbows like this. But so you have these two bones in your forearm. You've got the ulna on the medial side, the pinky finger side, and then you've got radius on the lateral side, or thumb. Radius is thumb, R-I-T. And when I'm standing in anatomic position like this, the two bones are parallel to one another, and the radius is lying lateral to the ulna. But I can perform this motion where I actually turn my hand over, and now my hand is facing down. When I do that, the radius is actually crossing over, so the radius is now crossing the ulna, and the two bones are forming like a big letter X where they crisscross one another. So this motion is referred to as pronation of the hand. But it's occurring, I mean, the hand is moving, but the motion is really occurring between the two bones up in the forearm. So that's pronation. And then the opposite motion is called supination. And that's where I simply turn the hand back so the hand is face up or supine, and that brings the bones back into alignment with one another so the two bones are parallel here in my forearm. The main muscle that's responsible for supination of the forearm is actually the biceps brachii muscle. Because when that muscle comes down from up here in my brachium, the biceps tendon comes down and inserts on the medial aspect of the ulna, or excuse me, the medial aspect of the radius, on the radial tuberosity. And so when I contract the biceps is pulling, up towards my shoulder. It's generating this pulling motion. It's actually going to pull on that radial tuberosity in such a way that it actually twists the radius. So I pull up on that radial tuberosity, and it twists the radius back into that supinated position. So it's primarily the biceps that's responsible for that. You've got a little wimpy muscle back here that's actually called the supinator, which also helps to supinate the forearm, but it's a very small, very weak little muscle. And if you're trying to do something that requires a lot of force when you supinate, like imagine you've got a screwdriver and you're trying to screw something into the wall, and you're doing this kind of motion, this twisting motion like this. This is supination. I start pronated and I twist into this motion. I'm supinating the forearm when I do that. And that's a motion that I would need in order to drive a screw into a wall. That requires a lot of force, and that wimpy little supinator out here can't generate enough force to do that. So it's depending on that biceps pulling up on that radial tuberosity to twist the radius into this position to powerfully supinate the forearm. So in addition to the biceps being a powerful flexor of the forearm at the elbow joint, it's also a very powerful supinator of the bones within the forearm. I told you that I would hold off for a second on describing the innervation of these muscles, because all the muscles in the anterior compartment have the same innervation. All of the muscles in the anterior compartment of the brachium are all innervated by the musculocutaneous nerve. That's one of the branches of the lateral cord of the brachial plexus. So the brachial plexus would be sitting up here, up in the axilla, and this would be the lateral cord because it's sitting in a more lateral position. And right there, the nerve that you can see is the musculocutaneous nerve, one of the branches, one of the terminal branches off of the lateral cord. And I mentioned this to a couple people in lab. You'll see it in lab again today, that one of the characteristic features of the musculocutaneous nerve is that shortly after it comes off the lateral cord, it enters directly into the belly of the coracobrachialis muscle. So you can see that right here. Here's the musculocutaneous nerve, and it's going right into the coracobrachialis muscle and innervates it. And then it comes out on the lateral side of the coracobrachialis, and at that point now it lies deep to the biceps brachii, and we'll see it better in the next slide, and eventually it ends up down here. And at this point now, it's a cutaneous nerve supplying skin of the forearm. But farther up here in the brachium, it's actually innervating all three muscles of that anterior compartment of the brachium. So moving on, we can now see the third muscle in the anterior compartment of the brachium. The biceps brachii has been removed in this particular view. And now we can see the third muscle. So up here you can see the coracoid process. Now you get a better view of coracobrachialis coming down, and you can see its insertion down here on the shaft of the humerus. You can see the musculocutaneous nerve entering the coracobrachialis and then emerging from the muscle on the opposite side. And you can see that musculocutaneous nerve, how it would sit deep to the biceps. But now you can see the final muscle, the third muscle in the anterior compartment, the brachialis muscle. And this would normally lie deep to the biceps brachii. Oh, by the way, before I start talking about brachialis, take a look down here. You can get a better view now of the distal tendon of the biceps brachii and see how that inserts on the radial tuberosity. And so it's pulling on that radial tuberosity that's responsible for rotating the humerus, or excuse me, rotating the radius to result in supination of the forearm. All right, so let's go back and talk about the brachialis now. The brachialis muscle is originating from the shaft of the humerus. So this whole area that I just kind of cross-hatched in, the brachialis is originating directly from the shaft of the humerus. And then it crosses the elbow joint down here and has its insertion on the coronoid process of the ulna, as well as the tuberosity of the ulna. So it's inserting entirely on the ulna. So it originates on humerus up here and inserts on the ulna down here. So the brachialis muscle is crossing just one joint. The brachialis does not cross the shoulder joint. It only crosses the elbow. So the only joint that it can act on, therefore, is the elbow joint. And hopefully you can tell that just like the biceps brachii, the brachialis is going to be a powerful flexor of the elbow joint, or flexor of the forearm at the elbow joint. As a matter of fact, the brachialis is actually a stronger flexor of the elbow joint than the biceps brachii is. So when people go to the gym and they do curls and they say, oh, I'm working out my biceps, it's like, okay, yeah, you are working out your biceps, but you're actually working out your brachialis even more. They just don't realize that there's a brachialis muscle hiding deep to the biceps. All right, the posterior compartment of the brachium includes two muscles, one very large muscle with three heads, and then one very, very small, kind of insignificant muscle. The primary muscle in the posterior compartment of the brachium is the triceps. And the full name for this muscle is triceps brachii, although it's not quite as important for you to put the word brachii in there because you only have one triceps. There's only a triceps in the arm. There's no triceps in your thigh or your leg or anything like that. So it's a little bit less important to distinguish. Triceps, as you might have guessed, gets its name from the fact that it has three heads, or three origins. The long head, which is one that you've already seen, because the long head forms some of the boundaries of the quadrangular space and the triangular space up here in the shoulder. That long head is actually originating up here. You can't really see it, but it's originating from what's called the infraglenoid tubercle of the scapula, so a little bump just below the glenoid fossa. And then you see the muscle, or the long head coming down here. The second head is known as the lateral head. That's originating directly from the shaft of the humerus on the lateral side of the humerus. There's also a medial head, which is mostly hidden in this view. You can't really see it very well, but it's originating from the shaft of the humerus in more of a medial position. It's just that it's completely buried by the long head in this particular view. The three heads all then converge together to form this very large tendon that inserts into the olecranon process of the ulna, one of the bones of the antebrachium. When the three heads of the triceps muscle contract, they're all going to generate a pulling force that's going to pull up this way, and that's going to pull up on that acromion process, which is going to have the effect of extending the elbow. So the triceps brachii is by far the most powerful extensor muscle of the forearm at the elbow joint. The long head, because it is attaching to the scapula, so technically it is crossing the glenohumeral joint between the scapula and the humerus. But similar to the biceps, it plays a very, very small role in movements of the glenohumeral joint. It can play a very small role in pulling the humerus posteriorly, which would be extension of the humerus. But that's a very, very minor role. Its primary job is to extend the elbow. There is another little muscle shown on here called the anconeus, which is sometimes actually kind of hard to find in the cadaver. It's this little triangular muscle down here. It has its insertion on this little bump of bone, which is just visible here. That's the lateral epicondyle of the humerus. So you remember at the very beginning, we were talking about these epicondyles that lie just above the trochlea and capitulum of the humerus. So it has its origin on lateral epicondyle, and then has its insertion also on that olecranon process of the ulna, right in this area. And when this muscle contracts, it's going to generate a fairly weak force roughly in this direction, which is also going to help to extend the elbow. So the anconeus plays a very tiny role in helping the triceps to extend the elbow. Both of these muscles are innervated by the radial nerve. The radial nerve, which is a large branch off the posterior cord of the brachial plexus, is the nerve that's going to end up supplying almost all of the structures on the posterior aspect of the entire upper limb. So radial nerve innervates these posterior muscles in the brachium. The radial nerve also innervates all of the posterior muscles of the antebrachium, and then it continues and supplies skin. It also has a sensory component to the back of the brachium, the back of the antebrachium, and even the back or dorsal surface of the hand as well. So you could say that the radial nerve is responsible for innervating pretty much everything on the entire posterior surface of the entire upper limb, all the muscles in the posterior surface of the upper limb, as well as all of the skin on the back of the upper limb. In fact, here you can see the radial nerve as it's passing posteriorly across the shaft of the humerus and passing in between all these different heads of the triceps. So once again, you can see the long head of the triceps originating here. Now you get a better view of its origin from that infraglenoid tubercle just below the glenoid fossa. You can see the lateral head of the triceps, which would have been originating from the posterior surface of the humerus, but in a little bit more lateral position. Now you can finally see the medial head exposed. That's originating from the posterior surface of the humerus, but in a somewhat more medial position. In fact, it's these structures, this radial nerve and the artery that runs with it, that actually forms the dividing line between the lateral head of the triceps and the medial head of the triceps. So you can see here's lateral head over here, originating in a more lateral position, medial head over here in a more medial position, and those two heads are separated from one another by the radial nerve sitting in the radial groove as it runs across the posterior surface of the humerus. And the artery that's running with it is called the deep artery of the arm, or profunda brachii artery. We'll talk about that more in just a minute. Sure enough, here are the arteries of the brachium, and I've also included on here, I've labeled a lot of the arteries that continue down into the antebrachium, into the forearm. And, you know, once again, when you first look at this, it's just kind of overwhelming that there's all these labels. But if you kind of go through it slowly, it makes a little more sense. So first of all, way up here is the axillary artery. And this little dotted line, this little black dotted line, indicates the point where the axillary artery ends, and the brachial artery then begins at that point. And that line is the inferior border of the teres major muscle as it's passing from the scapula over to its insertion on the intertubercular groove of the humerus. So as soon as the axillary artery passes the teres major, Now it changes names to become brachial artery. The brachial artery continues down through the brachium all the way down to the level of the elbow. And right about the point where it crosses the elbow joint, it then splits into two arteries. On the medial side is the ulnar artery, and on the lateral side is the radial artery. It should be pretty easy to keep these straight as long as you remember the names of the bones. The ulna is the bone that's more medial, so the artery that runs with it is called ulnar artery. The radius is the bone that lies more laterally, so the artery that runs with the radius is called the radial artery. So the arteries are named according to the bones that they're kind of running along with. So then there are a whole bunch of branches coming off of these arteries. Let's talk about those a little bit. First of all, there's a branch that comes off the brachial artery quite high. In fact, it may come off like almost immediately after the brachial is formed, way up here. But this branch is the profunda brachii artery. It has three different names because of the fact that so many anatomy books are starting to move towards more English names. I learned it as profunda brachii artery, which literally means the deep artery of the arm. You could also call it the deep brachial artery, or you could simply call it the deep artery of the arm. But again, remembering that in this case, arm is used in the anatomic sense, just referring to the upper part of the arm. So whatever you call it, this artery branches off of the brachial artery and turns posteriorly and runs along the posterior surface of the humerus. It's traveling right alongside the radial nerve. So when you're searching for this artery in lab, it's very helpful to look for the radial nerve because that's going to be a landmark that's going to help you identify this profunda brachii artery or deep artery of the arm. You'll see the artery and the nerve join together and pass, posteriorly behind the shaft of the humerus. Eventually, that profunda brachii artery is going to split, and it's going to give off. Once again, I've lost my cursor, so I can't see what I'm drawing, so bear with me for a second. It's going to give off something called a radial collateral artery and a middle collateral artery, which is going to run right down the posterior surface of the humerus. So profunda brachii splits into radial collateral and middle collateral. All right, if we then continue down down the brachium a little bit, there are a couple of other collateral arteries that branch off of the brachial. There's one up here called superior ulnar collateral artery. Books never mention this, but the easiest way to identify the superior ulnar collateral artery is that it joins with the ulnar nerve. And the artery and then the ulnar nerve together are going to cross right behind this bump of bone down here, which is the medial epicondyle of the humerus. So the superior ulnar collateral artery and ulnar nerve are going to disappear together through that can't find my cursor. Where are you? There we go. They're going to disappear together behind the medial epicondyle of the humerus. There's also an inferior ulnar collateral artery, way down here, which branches off just above the elbow joint, and it's going to remain anterior to the medial epicondyle of the humerus. So notice that we have two collateral arteries that are derived from the profunda brachii, radiocollateral and middle collateral. And then we have two collaterals that are derived directly from the brachial artery, the superior ulnar collateral here and the inferior ulnar collateral down here. These are four arteries that are bringing blood down towards the elbow joint and kind of surrounding the elbow joint on almost like four corners. If you imagine the elbow as being like a box and imagine that it has four corners. These four collateral arteries are going to join up with what are called recurrent arteries that are coming up from below. So let's take a look at where those are coming from. So over on the lateral side of the forearm, just below the elbow, the radial artery gives off a branch called the radial recurrent artery. And that's going to join the radial collateral artery coming down from below, and they're going to form a continuous tube. Now, you might wonder, okay, we've got blood coming down from above through this radial collateral artery. The word recurrent down here, radial recurrent, is referring to the fact that blood is flowing backwards. The blood in this case is flowing back up towards the elbow. Now, how in the world do you have blood flowing two directions through a single vessel? I'll show you that in a minute. I'll explain that to you. But this is what we call an anastomosis. You see that word up at the top of the slide. An anastomosis is where you have more than one vessel kind of joining together to form a connection. Okay, so that's an anastomosis between the radial collateral coming down from above and the radial recurrent coming up from below. There are also a couple of recurrent arteries coming directly off of the ulnar artery. There's an anterior and a posterior ulnar recurrent artery, and they are coming off of the ulnar artery, and they turn superiorly. They'd also be bringing blood back up towards the elbow. They're going to form anastomoses with the two ulnar collateral arteries coming down from above. So anterior ulnar recurrent forms an anastomosis right here with the inferior ulnar collateral. The posterior ulnar recurrent forms an anastomosis with superior ulnar collateral. And sorry, I'm just trying to clear my drawing again, right? And then the last branches, and you'll be looking for a lot of these branches, not today, but in our next lab on Thursday, when you're dissecting the antebrachium. Another branch coming off of the ulnar artery is called the common interosseous artery. The word interosseous literally means, in Latin, between the bones. And you might see why it gets that name, because it's lying in the space between the ulna and radius bones within the forearm. The common interosseous is frequently a very short little trunk. It may only be a couple millimeters long, and it very quickly divides into three other branches. It gives off an anterior interosseous artery that runs down the anterior surface of something called the interosseous membrane. You might be able to see in here, I've got all my scribbles in the way, but there's a membrane that connects the shaft of the ulna and radius. So this anterior interosseous artery is running down the anterior surface of that interosseous membrane. There's also a posterior interosseous artery running down the posterior surface of that interosseous membrane. And then finally, there is something called the recurrent interosseous artery. That's also coming from the common interosseous, but it turns back up towards the elbow to eventually form an anastomosis with the middle collateral artery. So again, we'd have blood flowing down through the middle collateral and blood flowing up through the recurrent interosseous, and they would then join one another to form an anastomosis. So I mentioned before, how is it possible to have blood flowing in opposite directions in a vessel? So this could be any one of those collateral arteries, the radial collateral, middle collateral, superior and inferior ulnar collateral, and you have blood flowing down through this vessel. And then these could be any of the recurrent arteries, radial recurrent, recurrent interosseous, anterior and posterior ulnar recurrent arteries. Blood would be flowing back up through these recurrent arteries. So they'd be branching off down in the forearm, but then flowing back up towards the elbow joint. So you might think, like I said earlier, how is it you can have blood flowing two different directions in the same artery? Seems like that blood's just going to crash into itself and have nowhere to go. Be like two cars trying to go opposite directions on a one-way street. They're just going to crash into one another with nowhere to go. But what you don't realize is that as these arteries get smaller and smaller, they're giving off branches called arterioles, which eventually feed into capillary beds. This is where oxygen exchange takes place, where the blood provides oxygen to the tissues and then picks up carbon dioxide from those tissues. And then that blood is then gathered up by small venules, which then join together to form veins. So blood would constantly be flowing out of these collateral and recurrent arteries into these capillary beds and then flowing back out through veins. So you don't just have blood crashing into itself here, trying to go two different directions at the same time through an artery. Remember that the blood is always being sucked off or siphoned off into these small venules and feeding into capillary beds. This idea of an anastomosis is extremely important in anatomy, though. And we'll come back to this several times throughout the course, because we'll see these anastomoses all throughout the body. The reason that these anastomoses are so important, and by the way, anastomosis, S-I-S, is singular. Anastomoses, where it's S-E-S, that would be plural. So if it sounds like I'm crazy because I keep changing the pronunciation, there's a reason for that. Anastomosis is single, anastomoses is plural. So there are a couple of reasons why these anastomoses are so important. For one thing, it means that you can have multiple arteries feeding blood into a particular capillary bed, which supplies blood to certain target structures like muscles and so forth. And if one of those branches is blocked, you still have blood flowing in through the other route, through the alternate vessel. So for example, normally we'd have blood flowing down through these collateral arteries and blood flowing up through recurrent arteries into these capillary beds. But if this one up here is blocked, for whatever reason, we can still have blood flowing through the recurrent artery to provide blood to these structures so that they don't die. If we didn't have these anastomoses, if you block just one vessel, you could suddenly lose all blood supply to a particular part of the body. We'll see later in the course that this is really important on the heart. The coronary arteries on the heart form a lot of anastomoses to allow blood to reach the heart, even if one of the coronary arteries is blocked. Same thing in the brain. There's a really extensive network of anastomoses supplying blood to the brain, so that if one of the four major vessels is blocked, the other three can still provide blood to the entire brain. But it's also something that we frequently see around joints, like around the elbow here that we're talking about right now, or around the knee, or even around the hip. You have these networks of anastomoses. Another reason why these anastomoses are important, besides just the fact that you can block one and still have blood flow through the other, the anastomoses can also function as a detour to allow blood to bypass a blockage. So for example, imagine that there was a great big artery somewhere. Whoops, sorry, that forgot to get my little drawing tools. So imagine there was a great big artery in the arm somewhere, like the brachial artery, for example. And normally blood would be flowing through that brachial artery to get from the arm down into the hand eventually. But let's say that great big artery somehow got blocked. And so blood couldn't flow through the brachial artery. You have these other side branches, these collateral arteries and recurrent arteries, that would provide alternate routes or detours for the blood to flow through them. So what would happen is you'd have blood that would continue to flow down through the collateral arteries, through the 4 collateral arteries around the elbow. But then that blood would continue to flow down through the collateral arteries and flow into the recurrent arteries down here. And eventually that blood would flow through the recurrent arteries back into the major artery beyond the blockage or beyond the detour. So, you know, to use an analogy here to describe this, imagine there was a huge accident on the New York State Thruway, and the thruway was completely blocked. What they would have cars do is they would get off at one of the exits off of the thruway and follow smaller roads past the accident, and then get back on the thruway at another exit farther beyond where the blockage was, beyond the accident. So these anastomoses can function as detours like that to allow blood to temporarily bypass a blockage somewhere in a larger vessel. And sorry, trying to get my cursor to click on the right thing. Come on. All right. So here's an actual example of when this could happen in the body, or in this specifically in the elbow area. So the brachial artery could experience a blockage around the level of the elbow. And if that were to happen, then blood could flow through all 4 of those collateral arteries, like superior ulnar and inferior ulnar collaterals, and flow down through the middle collateral and the radiocollateral, and flow into the 4 recurrent arteries down here. And then blood would then be able to continue to flow down into the ulnar and radial arteries, so that blood would continue to flow down into the upper limb, you know, continue to reach the forearm and hand. So you should look for these collateral and recurrent arteries. You should be able to see superior and inferior ulnar collaterals in lab today. Once we get into the forearm, on Thursday's dissection, you should look for all these recurrent arteries as well. And you should be familiar with this idea of an anastomosis, and be familiar with the connections that are formed between these collateral and recurrent arteries.